So for those who don't know IPFS, I'll explain it in a moment, but just as a quick introduction to where I'm coming from all of this, I'm in what's called a forward-looking threat research team, which means we're not really that interested in what's happening now. We're interested in what's happening in the future, far future, 3 to 5 years. Unfortunately for you, you have me, and I'm one of the people whose task was looking even further into the future. So I do a lot of AI stuff. I do a lot of quantum computing stuff, and I'm not going to talk about that at all today because I think most people couldn't care diddly squat about that. Maybe AI, but the other stuff. But because our team functions as scouts for Trend Micro, and if you don't know about Trend Micro, you're in a good club because it's or a very large club, because we're actually, even though we're one of the biggest computer security focused companies in the world, we're not so big in Europe. But our team focuses on the e-crime aspects and the user behavior changes that will lead to different different threat landscapes, and also technology changes. These are the things that we focus on. And as a part of that, a couple of years ago, we started looking into the metaverse because we thought, hey, this could be a new platform for doing business on, which means we have a new attack surface, et cetera, et cetera. Well, I think it really wasn't quite there yet. There's no clear architecture. But we did discover that there's a lot of combinations, a lot of things that lead into it, like the whole cryptocurrency, blockchain thing or so, the distributed application ideas, and there's smart contracts, and you probably heard of NFTs and things like that. And they kind of all, let me see, does this actually work? No, it doesn't. Oh, it does kind of work. So there we go. It kind of led to the IPFS idea. And this kept on popping up, and we also heard about this through other people as well, and so we decided maybe we should look into that a little bit more. Just backing up, though, even further, IPFS and a lot of the cryptocurrency things, and also the metaverse, kind of bring in this idea of Web3, which you may or may not have heard of. A lot of that is about ownership and control of your own data, leading to kind of like a trustless environment, permissionless environment, with a lot of decentralization ideas built inside. And the part that we are mainly interested in this whole landscape, this is what happens when you press the wrong button. So let's see, yeah. So is that area right in the middle here, the kind of the data distribution protocols, which is very much IPFS and Arweave, and it used to be CSGI, don't really know, doesn't matter, they don't exist anymore. Just to clarify though, there is Web 3.0 and there's Web 3, and they're two different things. This is just to keep your lives more interesting. Web 3.0 is based very much on Tim Berners-Lee idea about the semantic web and how we can also pull back a lot of our data into little data containers that we can then use. I think they're based on Solid, and we can interoperate with. Kind of a neat idea. Hasn't really caught on yet. Web 3 is similar in the way that they're also trying to decentralize things, but it's based a lot more strongly on using blockchains as kind of like a trust layer, as well as decentralized storage in the form of some things like IPFS, we'll see in a moment, instead of like little personal containers that you can either host yourself or have hosted at some other company. And in Web3, also this monetary aspect is everywhere in it. It doesn't seem to be separable from the idea as much. Both at least are concerned about getting rid of these siloed data ideas. Okay, but what is IPFS? Who's heard of BitTorrent before? Everybody's used BitTorrent as well? Anybody who didn't raise their hands, I do not believe you. But it's similar. It's not the same thing. It actually there's some significant differences, but it's similar in idea. So let's say you're called Alice. Anybody called Alice here in the audience? I don't know. So so you're Alice and you have this document, and you basically create this hash, this content address-based hash for that document, and you just let your document sit there, basically. But then somebody else comes along, let's say Bob. Any Bobs in the room? This being Germany is probably less likely. So Bob comes along and says, "I'm interested in that document. Who has pieces of it?" And we'll ask the Kademlia network, which is the foundation for IPFS, as it is also for BitTorrent, for peers who may have pieces of it. And then through the bit swap protocol, these pieces are brought into, are distributed to Bob. Bob says, "I want this piece. You have it. Give it to me." And then he assembles the entire thing. Central to everything is this content identifier, which looks like this. Is kind of a structured hash. It's not. I mean, it contains in the end, it contains this hash over here. Which is a real hash, and then the rest of it is kind of boilerplate. It's kind of neat. But the problem is they discovered after a while that this wasn't going to be flexible enough, and so they added another version, another type of CID. Now, the annoying thing for us is that these are pointing to exactly the same object. So we have to realize that even if we have one hash, we still need to calculate the second one from it. A little bit annoying. You can go in that direction basically from V0 to V1. It's not always possible to go from V1 to V0. And that's just because you can see in the bottom, well, actually you can't see in the bottom, but you can imagine that they've added more flexibility. So once you've gotten beyond what V0 can do, you cannot convert it back. What is an IPFS object? So on the command line, if I say IPFS cat and then all that gobbledygook or so, then I will just get a file like that. So just here's a text file as an example. It could be anything. It doesn't really matter. Underneath the hood, though, you can also do something like IPFS dag get and the same thing. And then you start seeing that it's actually a data structure. Now, this looks like JSON. It's not really JSON. In fact, that's also one of the parts in V1 that has more flexibility. It can be a quite complex structure, but it's mostly represented as JSON-like data. Now, if the object is too big, and by too big, it's like, I think 256K, I think is the limit, you have to start chunking it up into smaller pieces. And this is where, this is starting to be where IPFS is actually quite clever. So here, as an example, it has some of the data right in the front, so over here, but then that wasn't enough, so it continues on over here. So you add more data over here. And these things point to separate objects that can be called up and addressed separately. I'll get back to that in a moment. And then you can even go as far as putting like directories. Full directories can be put in there. This is, in fact, how you can host a website. You can create a IPFS directory structure with all the different objects now in separate files with separate file names, which are put into the main root object, and that way you can create decentralized websites. Kind of neat. We'll see how neat it is later. So CIDs are not quite cryptographic hashes, but they do have the integrity guarantees that you kind of need because buried in it is a cryptographic hash. So if you're wondering, okay, well, how about TLS? I thought I secure everything through TLS. Well, you don't need to because in theory you should be taking that object and checking that object against the hash code that's inside once you have everything completed. It's a little more complicated than just like checksum over the entire thing because of all these blockings. You have to do every block separately, and then you do the entire block. The problem, and most of the clients do this for you, at least the ones that we've looked at. But we'll see some exceptions later. Mutable addressing. So one of the problems that you might have noticed is that, well, we're using a hash. A hash can only refer to one single file. What if you want to change it? Let's say we want to update that document I showed before. Well, what they've invented is IPNS. I don't know why they call it IP name server. It's not really a name, but it allows you. It's a cryptographic a signature that can be then redirected from one to the other. You just have to re-sign it, re-sign the next document or the next version of it, and that's great. But it turns out there are other ways of doing the same thing because IPNS can be very slow, very slow. In fact, one of the problems is that what they do is they push these IPNS records out into the Kademlia network, and then they're basically gone after an hour. They kind of circulate there, and then they're gone. So the client has to be pushing them out like every hour at the very least. So some people say, I think the Kubo client, that's one of the standard ones, I think does it every 4 hours, and that's not always enough, I've discovered. So what they've done instead is they've invented new ways of trying to find these mutable objects, and that one is through DNS link. And DNS link is basically just a DNS entry. And now you kind of will scratch your head and say, I thought we were trying to decentralize these things. And now we centralized it again on DNS. Was that the point of it? Not sure. But this works, and this is actually what you see quite often, this approach. Now, you can also use the ENS system on Ethereum, so you can put it on the blockchain, query the blockchain, you get the and you get the actual IP and so to speak IPNS, so you get a name to a IPFS object resolution, and Unstoppable Domains also provides that same sort of functionality. Yeah, but not ideal. So, okay, so just to summarize it, what are the main differences between World Wide Web and IPFS? Well, World Wide Web is very location-based, so we need to know the server and the path in order to get at what we want. Here, all we need is this content ID, and we'll just ask the network, hey, I want that content. World Wide Web is a very strong client-server-like system, whereas IPFS is peer-to-peer, like you can think about BitTorrent. And of course, World Wide Web is very IP-centric. That's like your address for everything is some IP address. Whereas what we say is in IPFS is that it's Merkle-DAG-centric. What does that mean? So if you know anything about blockchains, you will also know that they use a Merkle tree internally, and it's the same thing for the documents as well. I should really have a better diagram for this, but Merkle-DAG allows you to do hashes of hashes. So when we saw this directory structure before, or the sub documents in the document, all these things have to percolate up to that top CID number. And the reason why it's a DAG, and a DAG means directed acyclical graph. There we go. Just blanking there for a moment. What's the G? By the way, there will be a test on this later. What's nice is that if you have subparts, like sub-document parts that are repeated very often, those don't have to be replicated more than once. So if let's say I push a website, and the 404.html document has not changed since last time, it also does not get a new hash number, hash code or CID, because it doesn't need it. And so that way we save a lot of space. This makes it a lot more useful for professional use. So how great is this? Well, as a computer scientist, I think this is really interesting and fascinating stuff. Unfortunately, the attackers have also found it quite interesting. But in any case, the reality of it is that it's actually quite a slow system still. Maybe it's just not big enough. I think that's our suspicion. The DHT and the bit swap protocol do take a long time to retrieve documents. I've sat there for like 3/4 of an hour waiting for some document to come in. So that's not so great. So you'll have the same experiences on BitTorrent. It does require an IPFS client. The Brave browser, though, does have support for IPFS, so it's kind of interesting. There's also a little bit of support in the Opera crypto, but they both, at least on the Mac, they both seem to require that you're running the IPFS client locally. But yeah. So one of the results is that sometimes these objects, you wait for them forever and they just time out. They never are there because they become globally unavailable, as we call it. And to combat this, they actually use, a lot of people use file cache to try to make these things more permanent. Basically, Filecoin. Filecoin is a way of paying people to host my content. And it's interesting because it's starting to see professional use. We'll go into that maybe in a moment if we have time. So IPFS and IPNS gateways are the consequence of all this slowness. So it turns out that people don't want to wait for their website to load, for more than 10 seconds. So instead, what people have are IPFS gateways, and there are a whole pile of public ones. But it also turns out that every node that you run can also be a gateway. So if in your infrastructure in your company, if somebody's running IPFS, they probably have a local IPFS gateway inside your company. As an example of how this would work, I can say, okay, first time on the first line, I'm trying to get it through IPFS cat. That didn't work. I try to go through one of the gateways. That was obviously overused. I could then go on to a different gateway, and then finally I get it through Cloudflare. Cloudflare also has an IPFS gateway, and so I load it, and it turns out that it's a virus. Well, not virus; it's a Trojan. So that's actually the good news there, by the way. So it's not avoiding antivirus solutions or EDR solutions in any way. It still will trigger it once it hits your file system. What the problem is, though, are blocking it at the URL level when you're talking about gateways, because there are a lot of public gateways. This is a list that somebody maintains, and this changes all the time. And as I said, you still have the problem of local gateways as well. But we want to know, how big is this problem? Is this really something that we should be worried about? So we looked into our telemetry data, and since we have a lot of it from all over the globe, that gives us a decent view of what's actually happening. So we've seen that IPFS kind of had been growing a little bit, and then it kind of slipped a little bit. It's kind of back down to early 2020 levels, and it's still very tiny. So this looks similar, but what we're looking at here are the percentage of all of the URLs that we see, and we can see it's actually a very small amount of our traffic, and that seems like it's good news. However, we did notice a decent amount of IPFS spear phishing based on IPFS, using URLs like this. And there's a whole pile of variants of this. So basically, you have these spear phishing attacks. You're not going to see it, but it's not visible. But you can see, for instance, let's see, so you won't see it, but here it's actually going through the fleek.co gateway as an example, and it looks like some sign-in page for some Redmond-based product, and we looked specifically into this type of spear phishing because it's very easy to find. And we saw that while the traffic of IPFS itself was going up and down, here we're seeing that IPFS spear phishing is steadily growing. It had like a little bit of a blip last year, end of last year. And we call that the CS guy effect, because what happened was this is like an alternative to IPFS, but they shut down last November. And so we saw suddenly a spike of the phishers basically moving their attacks to IPFS during that time. Just to illuminate that a little bit more, you can kind of see in the blue lines here, the blue ones are kind of going down. That's the CS guy phishing. I don't even know how to pronounce CS guy. Is it CS guy, CS ski? No idea. But in any case, they're gone. You can see that their traffic kind of going away, and at the same time, the IPFS fish rising during that time. IPNS is growing very slowly, but it's still growing. IPNS fish kind of had its moment and then it went away. Again, probably because of CS guy. And the attackers probably realized that, this is just not loading fast enough. Nobody's going to wait that long. The interesting thing from my point of view was I wanted to know, given, let's say, one CID, how many servers are hosting it at the same time? And so this is what I found in the statistics. It's a relatively fat tail. So I'm dropping, of course, the one-offs, because obviously there's a huge pile of servers that just host one object at a time. But then I've noticed that up to about 100 servers, it still stays pretty high. And that's a problem, because that means that once we have identified one CID that's malicious, we need to block them on all of the servers. We can't just say, all right, we'll just do that one server and have it over with. No, we have to do it for every single server that we know about at the time. Or we have to create a pattern. But patterns can be dangerous. if your patterns without the domain name. Blocking. So as I said, yeah. So just blocking that one domain isn't enough. Takedowns are, as you should realize by now, are totally impossible here. What we've done is we've tried to hack the protocol a little bit and try to get at the people who are hosting it. We did that in a simulated network, and we never got to that last person who actually originated the content. So the OG content was not reachable in our experiments. Well, we'll still keep on trying, obviously, see when we will find some method for doing it. Could you block 4001, which is one of the ports that's used for the peer-to-peer protocol? The problem is that there seems to be legitimate use for IPFS, unfortunately. Otherwise, I would say, yeah, just get rid of it. Like most people block BitTorrent because, hey, why would that be a thing inside a corporation? The problem is, apparently, there's two things. So first of all, there is a report that Netscape is using IPFS to distribute their containers, software containers, not these big metal boxes. So there was that, and then very recently I heard of various governmental research institutes and academic research institutes using IPFS to distribute their data, because basically, and that mainly using Filecoin. That was an eye opener, because I had been seeing all of this data that did not look like ordinary data, but I'm not sure whether it was encrypted or not. But that stuff seems to be coming more from these research institutes. So can you block it? Well, you'd have to figure out what your usage is of IPFS internally. The other good news is that malware is nearly non-existent. A colleague of mine did a study last year and monitored it for a month or so, found 180 samples of malware. When I went back and just went through the entire collection of objects, I didn't find anything. That's probably because EDR solutions kick in at some point and just get rid of it out of each individual system, and then it's gone. So it's no longer available in the network, unless you're the perpetrator. But apparently they don't keep it either. So the real problem is that we have some blind spots here. There are a lot of unknowns in the system that we're trying to track. We don't have access to our customers' XDR data. That would be super interesting if we did, but there's good privacy reasons why we don't. So I don't have perfect visibility over this problem. And we also have limited HTTPS visibility. So that's also missing from the data. But also the IPFS protocol, I think generally is just not being monitored very much. If I look at VirusTotal, I don't see any reports of them monitoring that protocol. So if somebody's using IPFS in their malware, we may not see it in the sandbox and things like that. This story probably will go on. Very recently, a piece of malware, PowerShell malware, was found, which actually had all of these IPFS gateways listed inside. So obviously, the malware authors are starting to think about this. And I am under embargo, but about the details. But I can say that a ransomware gang has announced at least that they are using it for IPFS exfiltration, as well as for also hosting their malware. That's something we're still looking into because it's a bit worrying. So, in conclusion, can you panic now? Anybody feel like panicking? No, I hope not, because it's still a very low value for the attackers. It's compared to normal fish, the volume's super low, and there's good reasons for it, because it is still an experimental platform, despite being around since 2015, I think. And I think they're just waiting for the IPFS system itself just to become bigger, and of course they're more faster. But it is hard to block. It's hard to take down. We like doing takedowns in our team, and when we can, and this would be very hard to do. We have blind spots there, but really the ultimate problem is that all this Web3 stuff, Web3, not Thread 3.0, Web3 is kind of venture capital's darling at the moment. They really They really like it. They're pumping a decent amount of money into it. And there's other incentives as well. Like a lot of companies in this field are DAOs, and so they've incentivized a lot of the people internally to work on this. And so what I've learned over the last 35 years of doing computer security is that you do not want to bet against technology. And so this is something that we feel needs to be monitored. It's definitely something, an attack surface to consider. So with that, I'm at my end. This is kind of me. That's our challenge coin thing. And I also want to just tell you about the Elbsides conference. If you happen to be in Hamburg in middle of November, we have a similar conference to this, but a lot smaller, called Elbsides, that I'm also organizing. And so I'd love to see you there. Thank you very much.
Thank you very much, Morton. Thanks for filling in. I remember I mined some Sia coin, I guess, but now they're probably more worthless than before.
Oh, so. Well, the coin might be still okay, but they've got rid of the distributed hosting system, I think.
Good to know. So we have some time for questions. Anyone got any questions for Morton? I don't see.
No.
So if not, then thanks again for the talk. Give it up for Morton, please.
Thank you.